In this video, I'll be talking about biopolymers. But more importantly, what are biopolymers? Biopolymers are plastics that come from a natural biological source, such as corn, cassava, sugarcane, and sugar beets. But what's the point of making plastics from natural sources when you can use good oil? The reason is because the environment. At the very start, people realized that if you take dinosaurs and make dinosaur juice to turn into plastic bottles that once thrown away lasts for all of eternity, probably isn't a good idea. We needed something sustainable, something natural, something that won't kill the whales. The answer was biopolymers. A side note, biopolymers aren't actually the magic bullet that will solve our plastic crisis. They are arguably about the same impact to the environment as normal plastics, so don't think of it as an end-all solution. PLA or polylactic acid is one of the polymers that will answer the call. To understand PLA, we first have to understand the terms monomers and polymers. According to Oxford Dictionary, monomers are a molecule that can be bonded to form other molecules, other polymers. Polymers are a substance that has molecular structure consisting chiefly or entirely of a large number of similar units bonded together. But this means absolutely nothing to you and I, so it's better to think of monomers like a Lego brick, a singular building block, and polymers as a collection of monomers that create the Lego corner, cafe, and hotel. In our context, our building block is lactic acid, an organic compound sourced from natural sources, and a polymer is a collection of lactic acid, polylactic acid. But how do we make PLA? It starts with the plant. For example, I'm using sugar beets. Sugar beets are milled into a paste, and the paste is turned into starch. So let's replace this with a more accurate picture. Starch is combined with alpha amylase, the same enzyme that is found in our saliva, to break down the sugar by breaking the carbon-oxygen bond to form dextrose. Dextrose is then combined with lactobacillus, a bacteria that turns sugar into lactic acid into three compounds, ATP, NADH, and pyruvate. From here, oxygen is starved from the system and the bacteria starts to use a spare H+ from NADH to ferment the pyruvate into lactate and further into lactic acid. Lactic acid is then polymerized using a process called condensation polymerization. This process is where an alcohol group and a carboxylic group bond to form a H2O molecule as seen in the diagram. H2O is then boiled off and the results are PLA and gaseous H2O. So now we have PLA. What's its unique properties? PLA is bio-based, which means it is biodegradable. It is a thermoplastic, meaning it can be melted and reformed without changing its chemical properties. It's a renewable resource since it's natural. FDA approved, meaning the United States Food and Drug Association has approved it for contact with foods. It's non-toxic and is easily printable. So what's its uses? One of its main uses is 3D printing. PLA's low working temperature allows it to be 3D printed very easily. Medical implants are also a great use for PLA, as medical implants require things to be non-toxic, and best of all, if it's temporary, it is biodegradable and can turn back into lactic acid at any time. Disposable goods are also a good use as it is a thermoplastic and biodegradable. Throwing away PLA can let it biodegrade into something that is mainly used in composting. Also, since it's a thermoplastic, it can easily be made into a packaging item. That's about for this video. Thanks for watching.